Good morning, everyone, and thank you for your interest in finishing automation, learning a little bit more about that. So if we can, let's get started, kind of a framework of what we want to talk about today. First, we want to look at some of the progressions you've made over the years in other areas of your facility, moving from more of a manual type to some type of automation. Then we'll look at manual spraying, transfer efficiency and why that's important. We'll look at some of the improvements by switching to finishing automation and what those look like. And we'll also look at your return on investment, which is important, obviously. So as you started out in your company, you may have started with a simple table saw like this to do your cutting, and you realized, I need to step it up a little bit. I need more precision. I need more production. So you transition to, here we see an ironwood sliding table saw, which will give you those things. But as your production increased, you could transition to something more automated. This HOMAG SawTech is a highly automated, very precise way to cut your parts. As far as drilling, this is pretty antiquated, but shows a point. You had to start somewhere when you realized I need more precise drilling, more production. You transition to something like this ironwood drill machine. And then eventually you possibly progress to this HOMAG Drill Tech series, which gives you the high automation and high precision for your drilling needs. The same way with sanding. I'm sure you've all has probably used a hand sander. It does the job, but it's not very uniform in its sanding application. So you progress to let's say a mid-range wide belt sander. You can increase your numbers and get your uniformity of sanding part after part. But production numbers increased, you transition to a more highly automated type, more precise with segmented pads, platen heads. So this would be in your next progression in your sanding area. Edge banding. Here we have a simple handheld edge bander, maybe possibly how you started out. Quickly realized you need to improve. So you could have gone to the HOMAG, the Edge Tech, but production numbers increased, demands increased. You progress to a HOMAG Edge Tech, fully automated, very precise, high production numbers. So why did you make those changes in your other areas? Well, one of the reasons is its efficiency. You waste less time. Like we mentioned before, your accuracy is greatly improved by making those changes. And that's going to improve your overall quality of your product. Those two combined is going to give you better production, which means increased profit. Something you may not think about, but safety. If you notice all those things that we looked at early on in the slides, they were manual operations. So you have someone physically doing those jobs and can be demanding on those individuals. All those things add up together for cost savings, material and labor cost savings. The same thing could be said and done for the finishing. If you've done any kind of painting at all, there's a good chance you started out with a cup gun. Now envision that cup gun holds a quart, 1/4 of a gallon of material. It's probably 3 to 4 pounds of weight sitting there as you're spraying with that cup gun. Quickly realized my arm's getting tired, I need something better. So you probably progress to, here's a gun attached to a long hose that's probably attached to a 5-gallon bucket, which allows the person to keep spraying, But we need to think about something. Once he finishes that part, he has to put the gun down, take that part out, bring another part into the booth to keep spraying. The goal is to keep those guns spraying as much as possible throughout the day. And kind of quickly pay attention to those filters in the back and the walls. Finishing is a dirty environment, and that'll kind of lead us into a point coming up here in a couple slides. So we've gone from cup gun to a better way to spray manually. And this is your solution for automation and finishing. We can greatly improve quality of application of the coating material, as well as production numbers. So let's kind of talk about probably how you're doing your finishing today, manual spraying and transfer efficiency. Transfer efficiency is the amount of material, the coating material that you're spraying, that's actually reaching the part. If you remember those filters a couple slides, they were dirty, the walls were dirty. That's the material that you've lost in that transfer efficiency. What can affect your transfer efficiency and in turn quality is gun angle, the gun distance from the part, your overlap as you're spraying that part. Are you overlapping correctly? The stroke speed, may not think about that, but is very important. And also the human judgment. If they're doing all those things correctly, they still could start out spraying great in the morning, but as they start to daydream, get tired, things can change. We know past history of studies that's done that manual spraying results in about a 30% transfer efficiency rating. And actually that's a little high. It's sometimes not quite that good. So that means out of the gallon that you purchase, only 30% is going on the part that you're spraying. As you can see in this picture, filters actually on his clothes and the floor. So it's an inefficient way to apply coating. Flatline finishing, we can give you 60% and sometimes more transfer efficiency. So there's an opportunity for savings. Let's say you're spending $100,000 a year spraying manually. Just by going to flatline spray machine, we can save you $30,000 a year. Now you're at $70,000 a year, and that's your first opportunity to start applying back to your return on investment for that spray machine. So that sounds good, but how can a spray machine save you that much? All these 5 things here, let's look at each one of those. So gun angle, maybe not think any of these things are that important, but if you notice the illustration on the left, the figure in the middle, the gun, that's at the correct orientation compared to the part. That's the way you need to spray. As you spray to the left and to the right, you need to keep that same orientation, but time and time again, if you watch sprayers in factories, they'll start cheating. They won't go all the way to the left and all the way to the right. So the coating starts to feather out on each end. A good coat in the middle of the panel and feathered out on each side. On the other illustration here on the right, notice that gun angle is tilted forward. It's not at a 90-degree angle. And that spray pattern coming out of that tip comes out in a V shape. So that if you're closer to the top edge there, you're going to apply a thicker coat. And opposite of that, the bottom side, it's going to be a thin, drier coat. So let's look at that, what that looks like in real life. Here, my gun is angled too far forward. And you can see I've sprayed way too much on the top edge of that pattern and not enough on the bottom. Here we're showing the opposite of that. My gun was tilted back. Now I'm heavy on the bottom and thin on the top of that pattern. So Now I know when I'm spraying, my gun angle is important. Now let's look at gun distance. Here's an illustration showing if your gun is too close to your part, you're going to apply too much material. You're going to take a chance on running or sagging. And on the bottom side of this illustration, here's showing the gun is too far away. It's going to give you a dusting or a dry, not a very pleasing application. Let's look at that in real time. Here, my gun is too close, a narrow fan pattern, too much material, and then the second, it was too far away. It's kind of a light coat. It's not attractive at all. So as a sprayer, gun angle is important. Now I got to keep in mind gun distance. I got to be thinking those two things. Next, I have to think about, okay, I'm holding my gun correctly, same correct distance. I need to overlap my spray pattern. I need to overlap that pattern by 50%. So let's look at what happens when you don't do it correctly. Here's one pass. I didn't overlap. And now an old term that's been used is cornrows. It's missing areas. It's light streaks. Obviously, that's not what we want. So we also have to think about stroke speed and the overlap. So one oscillation of a spray arm gives you a complete back and forth stroke. We know by oscillations per minute, in conjunction with the conveyor line speed, we can achieve the correct overlap part after part after part. You don't have to think about it, just load the parts. Stroke speed is important. You may not have realized that, but here's an illustration showing a fast pass with your spray gun, and here a slow pass. So my gun angle was correct, my distance from the part was correct, but I changed up how fast I made my stroke spraying the part. And that's a huge difference. So now there's 4 things I have to be thinking about spraying manually. I've got my gun angle. I've got to remember to keep that constant and correct. Gun distance, got my overlap to worry about, and now the stroke speed, all those tie in together. And if you miss one of those 4, you've got a problem. So let's look at how we can improve on that. How can we take some of those variables out by going to finishing automation? Here's just going to show this spray arm traveling back and forth. Notice the speed is constant. The distance from the part is the same. Those guns are fixed. They won't move. We've got those locked in to ensure we spray a good coat all around your part. And that line speed, as it's conjunction with the number of strokes per minute, we know our overlap is going to be taken care of. So, you know, finishing has always been considered more of an art, but there's things that we can do, just like we talked about, to make some aspects more of a science. So what is flatline finishing? Basically, it's a way to improve, it's a way to perfect what a human can do in the finishing area. We can greatly increase your throughput and your quality and uniformity of finish by moving to a flatline spray machine. Now, here's an example of an animation of what a spray machine does, how it works. This particular machine is a hybrid machine, meaning we can use a paper belt, or we can use a self-cleaning Mylar Teflon type belt to carry the parts through. Here we're moving, loading our paper onto our pickup roll, and we'll start loading our parts. Notice as the parts are coming in, there's a reading bar there, a sensor that's reading the dimensions of the part, So it'll know where the part's oriented on that belt and what that part looks like. And it sends a signal to the guns to fire off and on. This is how we can achieve a better transfer efficiency and get that 60% plus transfer efficiency. Notice the overspray is being pulled to the side through the filters via fans underneath those filters. And we can adjust and set how much overspray actually gets on the part and how much is on the conveyor. We have fans on top that push air through filters, so we got clean air coming in, as well as fans pulling that dirty air through filters. We've ran our green using a paper belt, and one other thing, that paper in most cases could be disposed of in just like you would your filters in your spray booth. Just throw them in a dumpster. So we've ran our green on our paper belt. Let's switch over and we're going to run red. We put our pickup tube into our solvent. We're going to flush the green out, switch over to the red. Here you can see that taking place. And we're going to be spraying on a self-cleaning belt. Some people call it recovery belt. Here we're reading those parts. We're doing the same thing. Very, very efficient, very consistent in application. But the overspray now, some coatings we can reclaim and reuse. A lot of water bases we can. So how this happens, our first initial scrape takes place, and we'll clean 95% of that belt. That product that we scrape, there's a chance we could save it and reuse it. The belt continues on down, and solvent is applied via a roll, and it's scraped again. So each revolution of that belt, we have a clean surface. So let's look at some common features of a flatline spray machine. First of all, the industry standard is 51 inches, a 51-inch working width, meaning we could run 4x8 through this machine and still get edge spray coverage. We talked about paper or self-cleaning. There's two different ways to use a conveyor belt. Here we're happy to show a paper belt. That reading bar we talked about, there's a series of photo cells. Those are spaced out about 12 millimeters or roughly a half an inch. So it's a very precise read that tells the guns when to fire off and on. Here we have an example of a large overspray exhaust fan. Some fans are placed underneath the filters on each side of the machine. This particular model has a very large fan, which is good for helping pull that overspray inside the spray chamber through the filters, and it gives us a lot of flexibility. The larger the fans are, the better we can control keeping that environment, that chamber, clean inside. As far as the control panel, we have a very intuitive HMI or human machine interface. If your operator can operate, if he can operate a smartphone, he can definitely operate the control panel. On the sides of each machine, that's where our filters are, and we have what we call two-stage filters. You'll have a section of filter on the top of that filter box you see, as well as another set of filters on the underneath there. So we're cleaning that air. We have two opportunities to clean that air. One reason why that's important, obviously we don't want to be exhausting overspray outside, but the cleaner that air as it goes through your fans, the longer those fans are going to work correctly. So two-stage exhaust filters are important. So we've looked at kind of what we call our standalone machine. We can take you from at that point all the way up to what we've got here. This is a highly automated, very precise a high production number Vinjacob spray machine. It has many advantages over what you saw earlier. This is a high production machine. Notice the spray chamber is larger than what we saw in the other video. The reason for that, the faster you want to run, the more material that has to be sprayed. So we need a larger area to expel that overspray. This particular machine also has a unique feature of 2 cleaning units. This is a self-cleaning belt. Most of the time, only one of those units is needed, but throughout the day as you're running, if that on other type machines like this, you may have to stop and clean that cleaning unit. Here on this Vinjacob, they've provided 2, only be using 1 at a time, and when it's time, when one becomes dirty, you easily switch to the second one. You don't have to stop the line. You can keep running and pull the first one out and clean it up. So it's highly automated, very precise, highly engineered spray machine. Now, we've looked at flatline. Here's an example of an even better way to perfect how a human sprays. This is an Evolution, a Maycore 5-axis Evolution spray machine. It's great for coatings or especially glues. You could spray any kind of glue application for laying up your vinyl wrap or whatever you want to glue up. So the 3D scanner is not just reading 2-dimensional like our other machines. It's a 3D scanner, so it's going to read the orientation of the parts on the belt. Notice the gun angle, it changes to mimic more what a human can do, but it is the same speed, same distance, that angle is constant, so we're perfecting what that human can do. Now, notice it's going to take 2 passes on these tall edges. That 3D scanner realized that and tells the guns, okay, we got to make 2 passes, and now we'll do the top. And that feature is very important. We could program it like for glue to spray 2 passes on the glue and then a single pass on the top. Notice as it sprays this one, it also has read there's an opening here. So I need to spray those edges as well, kind of like you might have on a face frame. It'll finish up the top and continue on. We can spray parts up to 5 inches tall. And in some cases, with some modifications, we can do parts up to 12 inches. Here it read that curve, and it also read that recessed area. Sometimes those are hard to get into, so it can spray inside that recessed area and do a great job. So that's a great way to, like I was saying, mimic what a human can do, but it's going to be consistent part after part after part. It doesn't get tired. It doesn't daydream. It's a great way to automate your finishing. So now let's talk about your return on investment. We know over the years, a typical standard kitchen consists of about 300 parts. If we say 1 day equals 8 hours and a labor rate of $25 an hour, we've seen if you have 3 people in your finishing department, it will take them 3 days to finish those 300 parts, resulting in a labor for that project of $1,800. Now, if you have a flatline spray machine, you'll still need those 3 people, but without a doubt, we can greatly increase your throughput. We can now do that job in 4 hours, from 3 days to 4 hours. So that's amazing. freeing up 2.5 days. Now that project, that same kitchen, same 3 people, is costing you $300. So that's a $1,500 savings, which is huge. There, that you can apply to your machine, paying your machine, as well as the coatings, and it's awesome. So there we saw labor, we saw the savings there. Coating savings we've talked about. Energy savings, how does that come into play? Well, if you've gone from 3 days of having to run your factory, run your exhaust spray, your spray booth exhaust, and now you're down to 4 hours, there's going to be some energy savings there. And you can utilize those people, those 3 people, put them somewhere else in the facility and utilize them there. We've improved quality. For the reasons we've shown, when you're consistent and uniform in your application, your quality is going to go up. With that improved quality, there's less rework. We saw what we could produce in 4 hours. Now the goal would be, okay, let's make more kitchen parts and let's produce more throughout the week. And happier employees. If you go back to that picture of the cup gun, that heavy cup gun with material in it, or that person spraying with the gun attached to the cord, the hose going to the pump, their arm is going to get tired. I've sprayed a lot over the years. I know firsthand you get tired. So you're going to have happier employees if all they have to do is lay the part on the conveyor and take it off of the conveyor. And you're going to have satisfied customers because of all of the improvements you've done to quality. All those combined together gives you a very smart investment for going to flatline spraying. So what is your goal? Let's answer the question, when is it time for finishing automation? If your goal is really strictly to improve your quality, if you have trouble getting sprayers or keeping them, them showing up, and that's all you want to be concerned with, for sure we can greatly improve that. If your goal is production, hey, if you got a new contract, I have got to be able to produce more every day, we can increase your production by 5 times the output. We can take care of that. But in most cases, it's a combination of both of those. When you can improve both, that's what we run into the most, and that is going to give you what you need when you go to finishing automation. So that's pretty much my presentation. I would like to, as we talked earlier, Taylor, introduced me. I'm the finishing product specialist for the Southeast and South Central regions of the United States. Munir is our West Coast finishing product specialist, and David Greer, he handles the Northeast and Great Lakes. So we've got you covered. If you need any kind of finishing help, you have questions, contact. If you're in these areas, contact the respected product specialist, and we'll help you. We have a lab in High Point, North Carolina, where we can prove these out, send your parts in, come in. If you can't come in right now, then we'll video it, and we'll prove to you that these machines do what they say they'll do.